to learn. And currently, it only works for SQL databases. So if your data is in XML, then R2RML doesn't work, although there are extensions to R2RML to work with XML. But the standard is defined only for relational databases. The third option is a tool that builds on top of the popular Google Refine, and it's called RDF Refine. And it is nice because it provides a graphical user interface. It has some support for linking and reconciliation, and it is open source, so it's free to use. And again, it only works for tabular data. But it's of an improvement over R2RML in terms of usability. But as far as I know, it is not R2RML compatible. So if you define your mappings in RDF Refine, they work with RDF Refine, but they don't work with the tools from other vendors. And the fourth option is our own tool, which we call Karma. And the nice thing about Karma is that it has a learning component, so that basically after you use it to map one or two museums, it learns and it can then make suggestions to map data from other museums. And even within the same museum, if you have many tables in your database. It has a graphical user interface. It supports the tabular data from databases, but also XML and JSON. And Karma supports multiple export formats. So we can export the RDF in different formats, but we can also export non-RDF. And this is often useful for applications. Karma is R2RML compatible, and it's open source. So let me go a little bit into more depth into each of the tools. So R2RML. So one of the things that I often do to sort of try to gauge how much uptake something has is I look it up in Google. So I look up R2RML tools. There are about 6,000 matches. So, an indication that R2RML is actually fairly popular. It is well supported. There's a lot of documentation, and if you actually browse the matches, you'll see lots of tool vendors that say, my tool supports R2RML. You can use it to take the database and map it to RDF. And this is very nice because then you're not locked into any vendor. There are probably people who are trained to actually use R2RML and so on. So R2RML, in my opinion, is a good option because it's a standard and adopted by many vendors and also many research tools. So our own tool actually supports R2RML. I think the Getty used another tool that also supports R2RML. So this gives a lot of flexibility. So as I said, 6,000 results. And you think about it, most people have not heard of R2RML, but there are a lot of resources on the web about R2RML. Now, I don't expect you to understand this. It requires training to learn R2RML, but the point of this slide is if you're using R2RML, you are expected to write things that look like this. Now, this is not going to be easy. It is a standard, but it's not easy. And if you want to find out more information, there's an excellent blog where I found this example of somebody who says, hey, here's my first R2RML mapping. And then below is the full documentation in the W3C. So here's Google, so the RDF refine. So instead of having to write things that look like this, which looks like code, I get to do the same thing in a graphical user interface. So here the example is I have an organization and it has a name and members and so on. The members are people and people have names and job titles. And you're basically using this interface to map a spreadsheet to the ontology. And so RDF Refine comes from Ireland. It's an extension to the very popular Google Refine, which is now called Open Refine. And so it's a good option. Uh, so it's one of the nice tools out there to define RDF. But I think it's not R2RML compatible, which means you do it in RDF Refine, you're sort of locked into RDF Refine. And you can find out more about RDF Refine on the web. So here is our tool. I'm not going to go into details either, but the idea is, again, to have a visual interface that explains how the data maps to the ontology. And so this, Karma helps you build this semi-automatically, and then you can visually see your mapping. So in this case, we have, for those who are familiar with CRM, all the classes have the prefixes E21 person, is identified by an E82 actor appellation, and then it goes on from there. It maps to the columns of your table, and then Karma uses this to create an R2RML mapping that looks exactly like this. So instead of writing code that looks like the R2RML example that I have here, you do it in this graphical user interface and you get the same R2RML output. One of the things that we did in Karma is we extended R2RML to work with XML and JSON so that it's not just for relational databases. And we can also do it for spreadsheets, Excel spreadsheets, and CSV files, and so on. And then for those, we create something that is very similar to R2RML, but Karma can interpret to create RDF. So that is really sort of the overview of the tools. Going back here. So basically custom code, R2RML, RDF Refine, and Karma. There are some other tools that have been created. I think there's one that's coming from the research space guys that's meant for RDF, for XML to RDF. I didn't list it here because it's a fairly specialized tool. The ones I listed here are basically tools to map data to RDF that work for any ontology and have been used in many domains in addition to cultural heritage. And my opinion is the advantage of that is that these tools, in a sense, are more mature, are getting more funding and more developers because they are useful in many applications. Okay, so let me forward here and talk about linking. So let me first introduce, so what is the problem with linking? So let's say every museum that does a mapping of RDF, and they all have artworks from John Singer Sargent. So every museum is going to coin a URI for John Singer Sargent, and you might think, why not have everybody create the same URI? And the answer to that is because it's a bad idea. because it does not obey the principles of linked data. And let me elaborate on that. So here at the bottom in green is Sam person. So the URI of Sam, and they have information about John Singer Sargent. Now, remember principle number 2 that says that if you look it up, the URI, you get data. Well, if you look up the SAM URI, it goes to the SAM server and gets the data that Sam has about John Singer Sargent. If I go to Dallas, and there's the URI for John Singer Sargent that comes from Dallas. If I look it up, it goes to the Dallas server and gets me the information that Dallas has about John Singer Sargent. And this is important because Dallas is going to have different artworks than Sam. So to know about John Singer Sargent, if I go to Dallas, I get the information they have and the artworks they have and so on. If we only had one URI for John Singer Sargent, it would go to one place and get the information from that one place. And then so the problem is, how do you reconcile that with having multiple museums that have data about John Singer Sargent? So the solution to that is, and then furthermore, there's other information about John Singer Sargent on the web. There's a long page in Wikipedia. The New York Times has information about John Singer Sargent. So what we want to do is basically link these URIs together. We want to say they all represent the same entity in the real world. So it says, the SAM URI for John Singer Sargent represents the same entity as the URI for Crystal Bridges and for Dallas and so on. So this linking problem, in part, is identifying these same as statements. And, this is not an easy task. And so here are some tools that exist for doing this linking process. So again, you can write custom code. This is actually very, very difficult to do, but you can get excellent results. There are tools like Silk and Limes, which work with RDF. They are relatively efficient, but they are experimental and have very little support. RDF Refine does linking against certain linked data hubs like DBpedia and Freebase, and it can be programmed to do it to other providers like VIAF or even another museum. The benefit is that it's nicely integrated with their tool, and it has a user interface for curation, so you can sort of do the whole thing. And Karma currently doesn't have a linking tool. We're working on one, but it doesn't have one. So here's a screenshot of how you do linking in Silk. Again, I won't go into the details, but the point is they provide a graphical interface where you take, say the magenta and brownish are two different providers, and you first lowercase them, and then you use some string metric to compare them. It's called Levenstein distance, and then the dates you compare them, and then you take the minimum and so on. So you do this in a graphical user interface, which makes it relatively easy, but it's still a fairly technical thing to do. And you can get more information about Silk from their website. This is RDF Refine. So again, it has a graphical user interface to do the linking. I won't go into the details, but this is so easier than writing code. and you can curate the results right there in Refine. And that brings me to the almost last topic, which is how to store and maintain the data. In my mind, we have really three storage options. The one that everybody talks about is about standing up a Sparkle endpoint. What this really means is storing the triples, the RDF in an RDF database, and putting a query server on it so that everybody can do queries to your database. Now, the problem with Sparkle endpoints is precisely that everybody can do queries to the database, which means that people sometimes do very expensive queries and they crash the database. And so Sparkle endpoints are very difficult to keep working reliably. They are comparatively slow, and they are esoteric. There are not a lot of programmers out there that know Sparkle. The main benefit is the query language is very sophisticated, so I can ask very precise queries. So standing up a Sparkle endpoint is a good idea but it needs love and care so that it stays working. An RDF dump is a complementary option. And so in addition to the Sparkle endpoint, one can take all the RDF triples, put them in a giant file, put that giant file on your web server, and then people can download it and do things with it. And so many application developers prefer this because given that Sparkle endpoints are unreliable, then you don't want to be querying them in your application if it's an application that goes to the public. So people download the triples and then do something in their own server with the triples. And this works relatively well. Another option, which I think is a much newer option, is to use JSON LD. So JSON is this popular language for representing data on the web that has become hugely popular. And there's a version of it called LD for linked data. And you can then take tools like Elasticsearch, which is, if you're familiar with Solr or Lucene for querying documents, you can use Elasticsearch. It's a newer version. You can use it to query JSON documents. The benefit is that Elasticsearch has an incredibly good performance. It's mainstream and it's easy to publish the data. The downside is that the query language is not as expressive as Sparkle. So here's an example of JSON LD, and I have this here for people who are familiar with JSON LD. It sort of looks like what programmers are used to. And this is important because I did a search in LinkedIn for jobs that related to JSON, and there were 3,500 jobs related to RDF, 61. So if the number of job postings is reflective of the number of applicants, then it gives you an idea of how many people know RDF, how many people know JSON. And let me close with applications. And I only have one application, which is from the BBC. So the BBC has gone into linked data in a big way. And this is a blog where they announce that they're making all their ontologies open source and public on the website. And this is the key sentence, which I will read because it's very telling. We have expanded the reach of linked data within the BBC because they've been doing this for about a few years. They did for the World Cup. So to more audience-facing products and presented our ambitions to using linked data as the glue for all the content that they produce. So they're basically connecting all their content using linked data. And so here's an example. Here's a page for Jarvis Cocker. I don't actually know who he is, but there's RDF for him on the BBC website, hand curated, so it's very accurate. And it also comes in JSON LD, which is very familiar to many, many people. So this is very cool. Because this means, this is of an example of a company that has a huge silo problem. They have, music, sports, science, everything. And they've used linked data to really break down those silos and connect all the data in their own organization together and to the outside world. So if you look at the last lines, it says that this Jarvis Cocker is same as Music Brains artist, so it's going out to the linked data crowd, to the Music Brains data set, and it's also going to the Wikidata data set. So this is very interesting. So that's it. That's all the overview of the RDF linked data tools and applications.
Thank you, Pedro. That was a very great overview, very thorough, but I'm sure our group must have questions. So let's open it up. You gave them a lot to think about.
It was
Diana?
great.
Yeah,
Yes, it was great.
It's a fire hose, I know.
Any questions? Just, to get the ball rolling and get people to open up.
I have a question. This is Kate Blanche from the Walters.
Okay.
Yes.
My question, I just wondered, when we're picking URIs for things, I mean, one of them would be our own museum URI for the artwork, I guess, but if there's multiple, how do we know which one to pick for a given thing? I don't know if that's clear.
So if there are multiple URIs, so you pick your own URI. If you're at the Walters, then something walters.com, I don't know, slash,
Yeah, okay.
slash data, slash artwork, slash, and then you keep going until you sort of narrow it down to the specific artwork that you have. And
so would you suggest that we have Perl set up prior to assigning a URI?
So you can have Perl URIs or you can have your own URIs. I think many people nowadays go with URIs that have their own domain names. And that's important because that gives provenance to the URI. So if I see a URI about an artwork in your museum and it starts with your museum domain name, then I know, okay, this information must be very accurate because it comes from the owner of this artwork. Somebody else has another URI about the same artwork. They might have useful information that you don't have, but the provenance is something that people need to take into consideration. So I would always put my own domain name on the data that I publish so that people know it comes from me.
Okay, that's great, yeah.
Hello, this is Barbara Akins, Archives of American Art. Can you hear me? Am I on speaker? Yes?
Yeah.
Okay. Pedro, are you at all familiar with encoded archival context, a standard for describing persons, families, and corporations? It's sort of a new standard in the archival field. And the SNAC project, which is a big, giant database of names that everyone contributes to. And as I hear you talking, I'm thinking, maybe we're considering investing our time into implementing EAC, and it sounds like maybe linked open data is the better way to go. It achieves the same sort of end result. Are you familiar with those projects?
I'm not familiar with those projects. I'm familiar a little bit with VIAF, which is another name authority that also has a RDF version. And so one can always, in a sense, link your museum artist to VIAF with same as links so that people can sort of navigate to other information. And through the VIAF identifier, say, go to the information in other museums.
Okay.
Yeah, I'm not familiar with those projects. So,
but Pedro, as you were just saying, when Karma is used, let's say, to generate the linked open data, more than one anthology can be used. So, I mean, that's one aspect, so that if there's a snack one, it can be used at the same time that the CDOC CRM, let's say, is used for some of the museum data.
Yeah, true. So, I mean, this is true not just about Karma, about any RDF mapping tool. So, even though I love Karma because I work on creating Karma, I'm not here to plug Karma. So, when you do the mapping with any of the RDF mapping tools, you can basically take your person URI and give triples in CRM, and you can give triples about the same URI in schema.org, in FOF, or this other ontology. So one can actually emit triples in different vocabularies or ontologies. And the advantage of that is that then more people can use your data. Because if somebody is in a particular subfield and they understand, I didn't get the name of that ontology, or say schema.org. If you take your data and in addition to CRM, you put schema.org triples out there, then Google will understand them and pick them up. And when people search, it'll combine it at Google and provide results that span across the multiple data sets that use schema.org. And you don't have to do anything. You just publish your data like you publish any website, and then people just pick it up, which is all the beauty of the thing.
This is Catherine Goodwin. Pedro, I just had a question about the Getty vocabularies, and maybe this is a very, very basic question, it probably is, but you had an example earlier of a museum referencing the artist authority record from 6 or 7 other museums. And does the union list of artist name being linked open data now allow us to sort of skip that step, ideally?
Yes and no. My slide was old, and I should have updated it to include ULAN now that it is available as linked open data. And so ULAN can become a hub. And so every museum could basically do same as with ULAN, and then you would really not have to do it, between museums. So you're right in that. The problem is ULAN is not complete. And so sometimes you may need to do same as to some other name authority. I don't know, you might have the subjects that are depicted in the artwork might not be in ULAN because they're not artists, but you still want to link them. Like, you have a picture of George Washington. I don't know if George Washington is in ULAN, but probably not. Yeah.
No, I understand, and so it's really a question then, I guess, of how many of those kinds of hubs are going to pop up, that are serving different niches in the art world.
Right.
Correct.
And Catherine, we're going to be hearing from Getty probably the week of October 25th about their plans, what they've published, and they're very anxious to collaborate with us. So as we proceed and as we get deeper into discussions of architecture of the American Art Collaborative, the idea of how we might link to some of these hubs will come up and be something we can talk about.
Great, thank you so much.
Anyone else? Okay. Pedro, thank you so much.
Thank you.
This was very, it was great overview, and I should have mentioned at the beginning, we forgot to mention that we are recording these sessions because there are always people who, can't make it. So this has been, been recorded, and we'll be posting the slides on the American Art Collaborative website. Is Shane still on? Okay, because I know.
Yes, sorry. Yes, I'm still here.
Shane, you had just mentioned to me in an email that about the website, something about upgrading it, or.
Yeah, we just this last week we just moved it to a little bit better server and just kind of tweaked it a little bit so it'll be